Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noe Pedro Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
What's going on, everybody? I'm Pedro Ruiz, Creative Tech here at Adafruit. Every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to make inspirational projects for you. Thank you so much for joining us. Let's start off the show with a lovely coupon code. That's right, today's coupon code is Color Swirl. If you'd like to pick up anything in the Adafruit shop, be sure to use the coupon code, Color Swirl.
That's right, to get 10% off your order. Expires at 11:59 p.m. tonight. Works on everything except AdaBox and gift certificates.
That's right. You know what else? Freebies! Adafruit.com/free. You can see all the free things that we have. $99 or more. We have lovely things like a permanent proto. Orders over $2.99 or more. We have more stuff. So check out Adafruit.com/free for all the tiers. We're going to take a moment to see why our thing is buffering. Pedro, what do you think?
I don't see any buffering over on Facebook.
Okay. It says our stream is healthy. Okay, cool.
Continue on with the show.
Yeah. I'm just like, there's always streaming. Yeah, it says it's sending data. Okay, well, we'll keep going. All right. Same day delivery if you need your order right away. The same day, you can do so. If you live in New York City, certain zip codes apply. Check out the website for that. Every Monday, we have a CircuitPython meeting hosted by Scott, and he does it every 2 p.m. Eastern Time. You can join in. It happens on Discord. So if you'd like to join in on that meeting, you can absolutely do so. Check out discord.gg/Adafruit. It's
over on the left side column of that. Scroll all the way down over to the audio channel for that.
That's right.
Every week, join Dan, Scott, Katney, and everybody who develops for CircuitPython.
That's right, and the lovely contributors.
The whole community is there.
So hello,
stop by, say
everybody.
hi.
We're in the live chat room. This happens 24/7, so if you'd like to ask, share, or just chat, everybody's there, hanging out. Just thank you guys for hanging out with us. All right, let's see what else we got. Newsletters, we're going to do this newsletter stuff. AdafruitDaily.com is the place to check out all the newsletters. There's different categories: CircuitPython, biohacking, and 3D printing. Yay! Product-specific newsletter is over at Adafruit.com/newsletter. You can check those out. None of those are spammy, so check them out. Good stuff in all of them. Would you like to use your maker skills to pay the bills? You can absolutely do so. Help wanted, Adafruit jobs board. Check it out. We're gonna jump right in there and see
There's
what
a
new
ton
jobs
more
are going
postings added.
Yes. Still got some great ones from Little Bits, senior project manager, mechanical design. Got Hackaday. There's some more down over here. Check them out. There's some very specific things like, yo, I got this library, and I got this OLED. I need help. So if you'd like to check those out, please do so. Electrical engineer. Need Flora programming for a small project. If you'd like to post up your job, you can do so. It's free for everybody. And we also have maker profiles. Is that Dave Estel's? Looks like Dave Estel's. Maybe it is. Hey, Dave. And we have a bunch of lovely folks that are posting up their maker skills. New faces. Cool. There's new faces here. Very cool. Thank you. Awesome. Cool. So check that out. Again, jobs.adafruit.com. Adafruit's gift to the community. Sweet. All right. Let's jump into this week's project. Heading on over to the Learn Guide, we'll see. This week we created a kind of a simple, fun, glowy project. One of our favorite ones. We love doing this stuff. Let's see here. Is it over there? Yeah. So this is this week's 3D Hangout project that we put together. We 3D printed a nice little sci-fi inspired bike light. But it can be a bunch of other things. It doesn't have to go on your bike. Maybe electric scooter. Maybe your persons. Maybe you're working on a prop weapon and you want some cool inspiration for design and stuff. So the inspiration was from like rocket boosters and jet engines and that sort of stuff. So I made this cool looking shape, and it's one of those things where you, if you're a designer, you've got this itch to make shapes. I just wanted to make this shape. Look at this shape. It's so shapy. It's dual extruded. I've had access to a dual extrusion printer for a little bit now, and I haven't really sat down and designed something specifically for it. So the goal here was to make this cool edge band that glows and then making these fins and stuff. Interesting thing is with 3D printing, you can make some crazy geometry. Yeah, really nice. If you do 45-degree angles, even 60-degree angles, you can make some crazy stuff that just floats in the air. So that's kind of how this thing starts. Pretty neat. Using translucent PLA with a mix of this black glitter-infused PLA, they make this kind of cool two-tone color-looking thing. So when you add some lights to the backing of it, you get some really nice light diffusion. So in here we got a 24x NeoPixel Ring and a 7 NeoPixel Jewel. So making good use of those there. You get this cool, interesting effect. There's your edge band. Here's where the microcontroller lives. It's kind of a neat way to make an enclosure. Normally I like to make a box that is kind of printed flat. This one's printed up ways, so you get that. So you get this kind of cool thing here. It's got a removable lid. You can take this off, and you can see all the guts inside there. We got a nice beefy 2200 milliamp LiPo battery. Man, there's a lot of cabling in there. You got a nice toggle switch to turn it off and on. And I'll just snap this back on there. I'm using the snap fits features here. There's these little indentations, and then there's these little knobs. Mate them together. It's symmetrical, so it doesn't matter how you snap it in. So that works nice. You got a nice toggle switch there. The feather itself is actually mounted in a separate mounting plate, and it's secured here. One of the reasons why I did that was to avoid printing with support materials. And then there's this really nice RGB LED button. Haven't used this in a project prior. And the really cool thing about this is the code is written in CircuitPython. That means I can plug this in through USB to any computer, and the code is accessible. Not just the code, the libraries are accessible as well. So if you want to make something that's accessible, that doesn't require an IDE to download or things like that, it all lives on the board, which is amazing. What does it do functionality-wise? When you press the button, we can cycle through different colors. Really sweet. The LED, since it is an RGB LED inside here, we can change the colors depending on what is kind of here. This is supposed to be like an orange color. There's more green color. And we just cycle through these different colors, and you can change and add new colors in the code on any computer. Pretty amazing. As long as the computer has, USB and Notepad or whatever. Seems to work well. So we're going to run through that and just giving a quick little demo. The way I attach it to a bicycle is with these 3D printed clips. It is designed for a 1.5 inch or 38 millimeters in diameter, but you can kind of change that. And we're using hardware screws and lock nuts to keep this thing secured to my bike. Big fan of JST PH connectors. Makes it easy to disconnect this, which is really useful. And we got this nice long cable so that you can kind of have some separation from your bike frame, because I want to attach this to the bike frame and this to the handlebars themselves. So yeah, the NeoPixels themselves are mounted just with friction fit on this little mounting plate that gets attached to the light diffuser. And there's a bunch of holes and stuff like that. I've tried doing something similar before, but I never had access or the ability to get an exact one-to-one representation of the board. But with EagleCAD and Fusion kind of working really well with each other, you can get, completely precise, accurate one-to-one models. It's really nice. So that's why all the holes are in the exact spots and pinouts and mounting holes and all that, which we'll take a look at. All right, so there's the sort of a demo of the project. Any questions or anything?
Nope.
Nope. All good? Audio still works? All right, let's go over to the Learn Guide. So there are just a couple parts. Most of them are in stock, which is surprising. We got the Feather M0 or the Feather M4. Those both will work fine. You could use an Adafruit Trinket M0 or an Itsy Bitsy. The reason why we're using a Feather is because you get some nice stuff. You get proto area, you get LiPo charging, so we can just plug in via USB and recharge that honkin' battery. It's pretty good. So there's the parts list, nice clean parts list, so you can just kind of grab those. Everything's in stock except for the toggle switch. This is a really nice toggle switch. It's beefy, it's accessible. I like it. The RGB button, it's a nice metal button. Feels nice when you press it, and you get RGB LED. Very nice. 16 millimeter panel mounted button. You could swap that out for a cheaper version if you'd like. You could use a regular 16 millimeter button. Yeah, we got tons of those. So it depends on whatever you want to do to change it. Yep. Also some hardware. These are the hardware screws that I used. We've got some metric pan head screws, some nylon lock nuts, and an assortment of JST pH connectors and things. Very cool. Also some screw taps, because I'm a fan of screw tapping my mounting holes and my 3D parts. So, well, that's a good thing. And then tools and stuff. So there you go. Prerequisite guides. If you're new to the Adafruit Feather, or you're new to CircuitPython, or NeoPixel in general, it's always a good idea to just kind of walk through these guides and take a look and take a tour from all the good stuff. All right, moving on to the circuit diagram. How's this thing wired? It's a nice visual representation of how to wire the electronics. The NeoPixels have some extra pins for power and ground and data, so you just follow that. All of our circuit diagrams are created in Fritzing software, which I link to there. We also have an Adafruit parts library, so if you want to make your own nice looking visual circuit diagrams, you can use our Adafruit library, and it's linked as well. I also link to just the individual parts. If you want to pick those parts, instead of having to download a gigabyte of parts, you can just download what you want, which is normally what I do. You might notice that the button is a little bit weird. There really isn't a Fritzing part that has an RGB LED button, so I just took an RGB LED and a regular momentary button and just slapped it on top. So that works well. Yeah, so you can download the Fritzing file if you want to modify it, download the Fritzing parts, and for accessibility reasons, all of the pins and things are written in text, so you can see the wired connections per component. It's nice. RGB button has a lot of wires, but hey, that's the way it is. Yeah. Toggle switch, just two. All right. The way to power this thing, you might notice that there's no battery attached to it. It's just kind of just to keep it kind of clutter-free. So that's why I have this little paragraph here. It says, how do you power this thing? Yeah, you plug the battery right into the JST connector that's on board the Feather. Another reason why we're using the Feather, because some of the cheaper boards, like the Trinkets and the Gemmas, they don't have, well, the Gemma does, but Trinkets and stuff don't have onboard JST. So you got to solder that in. So win for the Feather platform. Yay. And you have the benefit of adding on Feather wings. So let's say you wanted to do some data logging with GPS, or you want to connect it via Wi-Fi or LoRa. Those things are really fun to do. So
that's actually exactly what somebody just said, was so they could have a preventative feature for anti-theft.
Hey.
Definitely add some GPS.
That's very useful.
Upcoming project.
Yeah.
Really good code from Dave Estell's coming soon.
You know what's interesting about this circuit diagram can be used for a lot of different things, not just the bike light, like I said, maybe a prop thing, you know, cosplay prop thing. That'd be cool. So there you go. Software. This is where all the magic is. Again, CircuitPython. This is amazing. So if you're new to CircuitPython, it's really easy to get the CircuitPython latest version of it. Most of our boards ship with CircuitPython, but it's always a good idea to update as there's so much work being done in CircuitPython. It's getting better and better. It's getting faster, more lean, more green. CircuitPython libraries, so many of them. It's amazing. We've got the NeoPixel library, the Adafruit Fancy LED library. This is the first project I've used that uses the Fancy LED library, and Simple I/O. So those are the required CircuitPython libraries that you can grab from the bundle. So there's a link here. Download the Adafruit CircuitPython library bundle. Just download that and drag it into the folder that shows up when you plug in the Feather to your computer. How awesome is that? The code is hosted on GitHub, so if you'd like to contribute or fork or any of that stuff, you can check it out. This was written by Lamar herself, and I feel very happy about it because she wrote this on my birthday. It was really fun. It was like the best birthday gift. It's like, oh, isn't that great? Very, very cool. She has comments throughout the code, so if you'd like to add colors, switch colors, it's commented there in English, so you can kind of read it. I can kind of read it. So very, very cool. One of the reasons why the coupon code is color swirl is because that's one of her functions, I think. She called it color swirl. So if you are looking for similar functionality, check out the code. Good stuff. All right, move back on to the next stuff. 3D printing. So all the parts available to download, got STLs. If you are wondering if this is going to fit on your bike and you'd like to remake it, there's the dimensions in there for the bike frame and the handlebars, inches and millimeters. I always recommend dry fitting parts before starting assembly. So file out some edges, make sure the thing snap fit, make sure that it fits into the bike frame, all those sort of things. Tapping mounting holes is something that I was talking about earlier. I definitely recommend doing it as it improves the threading in your parts. So there you go. Or if you like heated inserts, you can go that route as well with a little bit of CAD modification. Yeah. Slice settings, everybody's printer is different, so you might have to adjust your slice settings accordingly. We're using an Ultimaker 3 with these slice settings here and slicing with Ultimaker's Cura because it works very well. When it comes to dual extrusion, you can dual extrude it in many different ways. We have the multi-material tool heads from Palette, for example, or the dual extruder from the Sigma BCN. They have a different way to do it, but more and more manufacturers are coming out with ways to do multi-material printing, and I'm taking advantage of it. But also, don't forget about the single extruders out there. So I also have single extrusion versions. You could potentially paint out, mask out the areas that you'd like to mask out, I guess. Do that sort of thing. Also, probably didn't mention the box is also dual extruded. Just from an aesthetic standpoint, I thought it'd be cool to have these kind of racer stripes on the side of the box, which kind of looks neat there. I also have did I upload those? I don't know, but Cura has it so that you can export a project file, and that's like so nice. So all the settings are there. You don't have to do any. You just literally just open that thing, and if you have the same printer and the same setup, all the slice settings will be exactly how I made it, which is kind of nice. Because normally it's like, you're on your own slice. There you go. It's normally how it is, but that's one nice thing. I hope to see that more in the slicers to have that sort of functionality. So the CAD files are hosted on GitHub. Check those out, as well as the code. I have the STLs as well, if you just want to print them straight away. If you want to modify them, the step file, that works in most CAD packages. And of course the Fusion 360 file, which is this .f3d, that includes a parametric timeline, modifiable sketches, textures, good stuff. So check that out. Oh, also the fitting diagram is there. Oh, nice. Cube. All right, back over here. I got a breakdown of all the names of the parts and what they do, just to kind of give you clarity of what it is, because there's quite a bit of parts, as you saw in this photo here. There's a lot of little bits to kind of clip onto your bike frame. So those are the pieces. What filament did you use? Someone would say. PLA from Filamentum. They have some really nice high quality filament. I'm using the Vertigo Galaxy PLA and the Rapunzel Silver. Also translucent PLA, which we happen to carry in the shop. So if you want to pick up this translucent filament, it's pretty nice. It's what I use to create this nice light diffusion effect. So there you go, some good filament. It comes in 175 and 2.85. So there you go. Same thing with Filamentum. You can get them from Matter Hackers or straight from Filamentum and even Amazon. So all good places. All right, now onto the assembling. I kind of run through a little bit. I like using JST connectors, as I said earlier, and we're using them here so we can easily panel mount the buttons, because otherwise you kind of have to solder the button, the wires to the button while it's inside the box, and that could lead to melty plastic. So, you know, it's always nice to use quick connects, whether that be JST PH or JST SM. This one, however, the box is designed around the PH stuff, so SMs are a little bit bigger. So there you go. All right, that's wiring the button. Wiring the switch, pretty similar. I really recommend using a third helping hand if you haven't before. It'll make wiring much easier, as it is a third helping hand. It helps you hold things while you're soldering, which is nice. Soldering the feather itself, all the button and the button and the toggle switch, they have corresponding connectors. So I just solder those into the feather. For this one, I'm using the Panavice to hold it up, because Panavice is nice. It's more of a square board shape, so that helps you keep the board straight and in place while you are soldering those wires in. Also want to mention the wires themselves are this really nice silicone cover stranded core ribbon cable. So it's got that ribbon cable. They're all grouped like that, and you can pull them apart like stringy cheese. It's 28 gauge. We have a couple of different ones. We have a 30 gauge one. This one is 1 meter long. They're back in stock, and I love this wire. It's premium wire. It's got that flexibility and a little bit more robust than your solid core wire. So you can bend it and flop it all over the place, which is nice when you're stuffing it inside an enclosure. And this stuff is really nice.
Or just when you're just soldering it.
Yeah. Yep. Cool. All right. The NeoPixel itself, a little bit bigger wire. I always suggest, I always have like noted what the wire lengths are, or at least that I use in the project. And this is a little bit lengthy. It's about 5 inches long, so that you can, you know, position it and things. The handle, once you're on the handlebar, you're going to make sure that there's enough slack and that you're not like disconnecting the JC connector. So it's a little bit tricky to solder this thing, mainly because the way the design is, I guess. The pins are accessible on the back of the PCB, and the mounting plate that houses the PCBs have these little holes so that you can thread the wires through there, and then you can kind of hoist it up on the third helping hand and then solder those wires that are threaded through the mount. Hopefully these photos help you. You can click on the photos to enlarge them to get a better look at this. So if you look here, you can see how I am kind of, you know, the part is kind of off to the side. And then, you know, another good tip is to use tweezers sometimes to kind of hold so you don't burn your fingers. My fingers tend to be meaty and big, so I like using tweezers to kind of get that in there. Be careful not to melt the plastic. So
yeah, something that we saw right after we had done filming and writing the guide and everything for it. In the model, you could actually make a slit around the entire thing and have it connecting with like how a stencil is. We did it for a design for a past project before, we just totally forgot about it, but that'd probably be the better way to have those instead of having the little individual holes for each. Yeah,
it's a little bit more difficult this way, but it's nice that you have a flush surface. The PCB is on a flush surface. That tends to be the problem when you do it that way. You have these wires that are underneath the PCB and it's not quite hosted in there, but hey, it's a design thing. Soldering up the NeoPixel Jewel, we have plenty of power and ground. Also that the 24X has shared power and ground, so you don't have to share the pin, you just have this extra power and ground. You do, however, want to make sure that you are soldering, it's kind of interchangeable, but in whether you want the NeoPixel Jewel to be like the first, what would you call it, the first set, because you have to, NeoPixels can be daisy chained, right? So you have a data in, and then the data out flows into another data in. So that's the way I set it up. Data in is going to the pixel ring, data out goes from the ring to the jewel, and that's how I have that set up, so that's why it's set up that way. Same thing, we got to thread it into the little holes and solder that in place, and I have these extra wires that kind of they get soldered into the NeoPixel Jewel, so they really are sharing power and ground just through different pins, which is nice. Love those extra pins. So there you go. That's how you wire up the NeoPixels themselves to this thing. A little bit difficult, but it's gets a nice nice effect.
Definitely worth it.
Yeah, nice and secure. So definitely want to test it out before following through the rest of the assembly. On to assembling the headlight. So this mounting plate, just line it up with the tabs on the diffuser. There's M3 holes there, so you can just attach them with those screws. It's pretty nice there. And then attaching the headlight clips rather. There's these two tabs, square tabs that are on the outside of the mount, and those get press fitted in. And then there's a special little, what would you call it? A special little kind of recessed area with a hexagon shape sized for a lock nut, an M3 lock nut, so that the print itself will hold the lock nut in place while you're fastening. Nice. That's the sort of things you can do with 3D printing. All right. So there you go. That's the fully assembled headlight. So the mount for the feather is its own little part. It's symmetrical, so you can orient it in whatever way. Was it 4 or 5 millimeter tall standoffs that are built into that little mount. I recommend threading them with a screw tap. They're M25 sized, as it's written there. And you want to use, I suggest using flathead screws because they have tapered edges. If you use a pan head screw, you might kind of interfere with one of the chip LEDs on board the Feather. So be careful if you're using button heads, pan heads, as they're often called. I don't recommend those. I recommend the flathead ones. These are kind of nice. I also link to those in the overview where I like to get my screws from. Cool. On to the case assembly. I start off with installing the components, the panel-mounted components, the button and the switch. So just kind of fit those in, and they come with their appropriate hex nut hardware to kind of attach it. The switch has 2 hex nuts and a washer, I believe. So I don't think I used the second washer, I just used the first one. So however you'd like to do it. That hardware is included, so that's nice. Talk about orientation, things like that, to get the optimal position for all the things as you read through it. Yeah, install the battery. The battery has this little, or the case has this little kind of curved clip for the battery to fit into, so that's the way it's fitted into. You don't need any thumbtacks or sticky tack or anything. Just, you can do a lot with 3D printing. Like you can design all sorts of holder and things for batteries, and this cylindrical battery fits nicely inside the corner here of the box. And then before stuffing the feather mount, you want to connect the battery. Otherwise you won't have access to it once it's secured in there. And we're just using 2 screws to secure the mount to the box. There you go. With all of the connections on the outside, you can connect all the JST feathers. One little tip is to avoid connecting the wrong connector. I reversed the male and female connectors, so I wouldn't confuse the button and the toggle switch, because they both use 2 pins. If I had them both have the same male and female connectors, then I could potentially connect the wrong one. You could also use different colored wires or labels or even heat shrink tubing to differentiate the connections. So that's always nice to consider. And then the clips have a little bit of a T-slot, and there's a railing that's built into the case, and you just slide it in and it kind of locks in there. You may have to use a filing tool to loosen it up a little bit, but you want it to be really tight so that it doesn't slide around on your bike or wherever you're putting it. And then the final NeoPixel test, make sure everything still works. Attaching it to the bike is the last steps. So I'm using longer screws. These are 10mm long screws, M3, and some lock nuts, some nylon lock nuts. I actually 3D printed the little socket adapter because I didn't have one for that size, so that's always nice. Same thing for the handlebars. There you go. Final form. Sweet. All right, so that's the project in a nutshell. Kind of ran through that, but if you read through it word for word, it's pretty descriptive of what how to do it. So pretty neat. I'm gonna jump over to the CAD just to show that off a little bit. So here's the kind of CAD assembly. Not the best organization here on the side, but whatever. I really needed a way to visualize how these parts were going to snap, so I designed these little tubes to kind of act as the bike. That works out well. It's not really, not using user parameters, and I kind of wanted to rush this one, but it's totally doable. If we look at the electronics, you can see the PCBs here. These are available on our GitHub parts library. Even the silk screen shows up, which is super cool. But as you can see, the pins are kind of spread out across the PCB. So that's how I was able to get absolutely correct one-to-one representation. Here are some other components. This is the Feather M0. It's fitted over there. We have the battery. And they're really, really close. As you can see, it almost looks like the pins are smashing into the button there. But because of the way I actually am not using headers, so I'm just kind of disregard that. And if you want to update these clips to fit your bike, you can do so as well. Each one of those are their own components. For example, if you wanted to take the bracket, you can isolate that, right-click, isolate, and you can modify it. I like to have my timeline with this option here. If you hit the little gear icon, you can see here it says hide all inactive features, and that'll just clean up your timeline so you can only see the things that are pertaining to that component. So if you wanted to change the diameter here, you can open up the sketch and then change it here. This is how thick I have the thing itself. If you want it a little bit thinner or thicker, you could change that if you'd like. Just kind of nice. Think okay?
Yeah, just laughing at the comments here.
Oh no.
No, it's good stuff.
Oh, okay. It's like, oh no, I'm failing. What's going on? All right, so there's the CAD stuff. A lot of fun. Cool. That's the project. I'm going to move on to this right here. So the CAD parts are available to download, so you can check them out right over. Where are we? I think I lost the page. Is it this one? No. Whatever, it's on GitHub. I have a link down below in the description. Some new parts that we added to the GitHub is actually still right here. Now let's go back into CAD land. Tunnel, CAD land. There we go. You got a 16mm button. This is, PID is there. This is like one of your more basic buttons, 16mm. It's got the threading and stuff. This is the battery for the lightsaber. I added it to our GitHub repo so folks can download that. It's a pretty accurate measurement of it. So it's a nice, they're just two 2200s slapped together in this little band. The RGB LED button is here as well, so you can download that, get that. This is nice. This is the micro USB breakout. And this one has two mounting holes, so for example, if you wanted to break out or extend the USB, you can use one of these guys here. So it's kind of nice. I used it on the lightsaber project as well. Speaking of lightsaber project, the prop maker wing is also available to download. Traces are in the back there. I wish the silk screen showed up, but for whatever reason they didn't show up. Eagle's working on that, I hope, because when you use custom template layers for your silk screen, sometimes they don't show up. So
I think we put the request in. It's probably some other things I got to fix around it.
Also, I got this Pico Blade connector there, which I downloaded from, I believe, DigiKey. Shout out to DigiKey. They got nice CAD parts too. Got a nice trim pot there, so you can access that. Reset button, and this new 3-pin JST male connector that's on the board itself. So there you go. So if you want to make some props with the prop maker wing, download this guy. That's it. Those are all the parts that are up on GitHub. Let me just go ahead and go to there. GitHub.com/Adafruit/Adafruit_CAD parts. There they all are. If you'd like to contribute, you can do a pull request, and I really appreciate that. If you have some requests, you can file an issue as well, and I'll get to that as I get there. Sweet.
You know, subscribe and get notifications anytime new parts are added.
Yeah. Apparently people have 79, and there's 8 forks. Cool. Ooh. Okay. Yeah, I also added a library, an MIT license, so if you want to, it's open source, as open source as it can be. All right.
Cool, that's cool. Comments in the chat going on.
Yes.
Yes, this will definitely fit on a scooter.
Excellent.
Yes, we did
I'd love to
that.
see somebody make it and put it on their vehicle. Obviously, you want to be very concerned about the laws. It could be illegal in certain areas, so make sure you check your laws.
For the color of
For the
the
color
light.
of the light, yeah. It's like it's not allowed to be anything other than white or yellow, and it gets confused with a tail light. Maybe you do want it to be red, and you do put it on the tail of your light.
Can't go wrong with a rainbow color swirl there.
Yes. Very cool.
Let's see. I should have highlighted these.
Yeah, we'll do it next week.
Yeah.
Yes, we need more Colin's Lab. I agree.
He is.
That is why I subscribed here. Where's Colin?
Scripts
he's
scripts take a while to write.
Yeah. He as well. Color swirls, coupon code.
Don't forget to use that. 10% off your order. Expires at 11:59 p.m. tonight.
That's right.
Oh, cool. Let's move on to this week's
Shop a Taco. All right, you want to go with the box? What's in the box? Tell us. All the way from Czech Republic.
Yes, so I want to say beginning of the year, we put in an order for this. We wanted to check out the Prusa since everybody seems to have gotten them.
Prusa.
And it looks like there's still a long wait. Yeah. But it finally came in. We got the multi-material upgrade on that. We'll be testing that soon. But the first thing we wanted to do is just make sure that it operated well out of the box. Super easy unbox here. We didn't get the kit version. We just got the assembled version. And lo and behold, it worked really good out the box.
This is a super awesome open source printer. Actual
I was surprised at how small and light the actual printer, like all of the components were. It's a direct drive, 1.75, and the first thing we wanted to print on this was a phone case.
Where's my phone? Phone case, it works. I broke mine and I printed this one on there.
Yeah, one of the first things that we worry about when testing a new printer is, oh my god, how are the tolerances?
Dimensional accuracy.
It works just as good as all the Ultimakers. So all of the sizes, all the fittings, they all should work. So anything that we design for it, because we are going to be doing a lot more multi-material testing for this, should work out pretty good.
Yes.
The second test was a little unusual. I tried the wood fill and it did a pretty good job. All of the printers that we've ever used wood fill come out just like this, so this isn't fault.
Expected.
Yeah, it's expected. It cleans
Retraction
up really nice.
Is on. It's just it's an oozy type of
pretty oozy, yeah.
Interesting thing about the nozzle, it is what, an E3D hot end, all metal hot end. Yeah, so it really works with flexibles. It works with flexibles and composites and all that weird stuff people are making.
Yeah, the included filament works pretty good. I like the gray color that they have here.
Right. Heated bed, by the way. Heated bed with PEI. You heard it right. Where's Kirby? Kirby? PEI. We finally did it. High five.
We're using a Raspberry Pi, Octoprint. One quick tip that I forgot, make sure you're using a Pi 3.
Oh, yeah.
Otherwise, you are going to have some slower, weird tool retractions, as you can see right there. Yeah. Second thing I did was...
I never thought that was a problem.
I had forgotten.
So
since using all the Ultimakers, all that's built in, and you can contribute to Octoprint. We have been for a number of years, even after we stopped using it.
Yep.
But yeah, everything worked out pretty good. There was no unusual weirdness that happened with it, which is always good because it, testing out stuff definitely takes away time from projects. So we're happy to report that, it has been added to our arsenal of printers.
Such a fancy printer, it doesn't even need to print. It just prints in thin air out of magic. Now, this is a plugin called Octolapse, which is one of the benefits of using Octoprint and a Raspberry Pi. You get Wi-Fi connectivity, and you get the community of developers who can make interesting plugins like this one. So this will tell the printer to park over there and tell the bed to stay over here, and then it uses a USB webcam. We're using the Logitech C92 webcam. And you can take these amazing time lapses.
Yeah, this is
amazing. With a regular GoPro, you would see the bed moving. You wouldn't even be able to see the part, and it'd be blurry. But with Octolapse, you can get this phenomenal effect where it's just like growing out of thin air. Pretty cool.
This looks awesome. And the really cool thing about it, is there's no setup. Usually for time lapses, we got to set out the camera and make sure the lighting's all right, their intervals all.
This is just a test.
Yeah, all our exposure, all that crap. This just works.
Let's look at the parts that we printed on it, so we can. Take a look at the phone first.
Here, since we were just looking at the lightsaber pen, really cool model on Thingiverse. We'll link that in the show notes. It is meant to hold a pencil, so super cool, simple. Checking out the quality for that. Looks just as good as the Ultimaker.
There you go. Yeah, there's some overhangs and things that the printer will struggle with, but that's just there you go. It's working out.
Yeah, should have been some like fillets and chamfers on here.
Yeah.
Or
the more interesting is like to see how the old Pi versus the really like performance of the Pi.
Oh, it's just how many. It's the baud rate that's able to send the tool path for. So
same printer, the Prusa.
Yeah. Same G code.
Pi B here and Pi 3 here. How interesting! Look how disgusting that looks. It's not the printer's fault. It was the Raspberry Pi's fault. Does anyone else have that issue?
So when I Googled this issue, there was like 6 pages deep there was one person who mentioned this, so worth repeating if you're getting some funky tool paths. It's not your slicer, because I tried like 4 different slicers.
That's right. That's what's cool about that's what's really cool about the Prusa. You have options for slicers. You can use Cura, or you could use Slicer, or you can use
Simplify 3D.
Simplify 3D. Yeah, so these are pin add-ons. You put a number 2 pencil in there, and you get this nice lightsaber pencil. Pretty cool. So those are some parts we printed. Also, this is really practical, really nice surface quality here. It's an iPhone case, but hey, it snaps in.
Pretty good job.
Really nice.
We also tested out, I didn't get a chance to offload the footage for this. We did SemiFlex printing, since they do tout that they can print NinjaFlex, so we'll be trying out that. Next, did some very simple little Mickey ears for that, and this is just SemiFlex. It did not adhere, or like fuse to the bed, so that's good.
Yeah.
It was able to come off pretty quick, pretty easy.
Okay.
And I think the settings for this is just like 50 millimeters a second.
Really?
No, I'm sorry, 40.
It's gotta be 40, yeah. We
40
tried
millimeters a
50
second.
and it kind of didn't work.
And very happy to report that it did a really good job, even on like on the details, on like all the small things. Usually the printers have trouble with that.
Focus.
Especially all the little detailed parts.
Yeah, it's very difficult to print.
It did a really good job.
Super important on this one. And anyway,
very happy with it.
Sweet.
Cool.
Flexibles, yay.
Yeah,
we got a lot of 175 filament. So as well
as some of the other materials. We don't really print with like the PETG and I forget the other ones, ABS and a couple of other ones. It does a really good job. All the presets are all there for it.
Apparently the parts that are on the printer itself are printed in PETG.
Oh, okay, yeah.
Yeah, PETG thing. Well, that's what Kirby told me.
Yeah. Kirby's sending easy. Is it next week? No, is it?
2 weeks.
2 weeks, yeah.
Disney's in 2
weeks. Yeah.
Yeah, if you guys would be out there,
yeah,
say what's up.
I'll bring you one, Kirby.
Meet up with Kirby.
Print another one set. Glow in the dark came out good. So if it was able to do the SemiFlex, should be able to do a really good job with the Cheetah as well.
Yeah.
The next thing I'll try is just a regular 85A NinjaFlex.
Yeah. The ultimate test, multi-material. I would really have loved to have had 4 materials on the lightsaber, because I had 2 colors and then I needed support material. I'm really a big fan of breakaway supports or scaffolding, whatever it's called. Whoa. So that would have been nice to use. So maybe we'll test that out.
Cool. Dave is saying that his the MK3 actually has the Pi Zero built in. Try printing a circle, because the case over there was printed with the Pi B, and it came out perfect. That's why I didn't think that it would be the Pi.
Well, it doesn't have all this crazy geometry.
Yeah, try a cylinder.
Okay.
Let me know how that one works, because all I did was switch it out to Pi 3 and exact same G code, and it printed very well. All these cylindrical objects.
Sweet. And we'll be doing some more time lapses and stuff. This is just a little test. I think we're gonna get a better USB camera for this, but you kind of need to be a USB camera, because
I think we could
lapse is what's telling the thing to take the photo.
I think what I'm gonna do is just grab another one of our intervalometers, cut the cord on it, and just hook it up so that the so it just triggers it. So we'll have like 2 angles at the same time.
That's a good idea.
For that.
Another thing to note about this, which I didn't even consider, is that it actually increases your print time, because it has to park and it has to take the photos. So it's fine. It's fine. I mean, you're going to get this really sweet effect. So very cool.
Yeah, I thought that we had ordered a MK3, but
yeah, it was back in April. And then we got a voucher code for the multi-material unit, because they were in the process of updating it. So at least we got the latest for that one. So it does have some nice features, like it has an auto probe leveler, and it does like how many points of leveling?
I forget. Is it 9? Something like that?
Yeah. So yay, Prusa.
Yeah, maybe it's the older board? I don't know. He said he printed cylinders just fine with the Pi Zero, which is funny, since I could have swore Octoprint said it does not, that they only recommend Pi 3s.
Yeah. I downloaded it like the day before yesterday.
The image for it, yeah.
And it was like, hey, use a 3. Stop telling us this and that.
Oh yeah, it's probably for support issues. It's
9
like, I don't want to hear it.
Got it.
Yes, 9 points. Super fast, really good. A little Z probe for that. Can't wait to test out the multi-material stuff.
Yeah.
Cool.
Cool. Well, that's Shop Talk for now.
Yeah.
We're gonna move on to Community Makes. We got a time lapse every Tuesday. We We do a time lapse of designs from the community, sometimes our own, but mostly other folks, fine folks that design cool things. This one is kind of special. This one's neat. This one has a little bit of history to it. Okay, what is it? What is it? What is it? What is it?
This is called.
Tell us in the comments.
Think a Dot.
Think a Dot.
I've never heard of this.
Replica.
Yeah, this was posted on Boing Boing. PT saw this and was like, print me up one.
Yeah, this is cool.
That's awesome.
Yeah, so shout out to Michael Gardi who designed this, and we're gonna walk through his post as it's quite interesting.
Yeah.
So this is Pedro assembling it. It's different parts, multi-part thing that snap fits. No hardware exclusion needed.
No. It's
Okay,
all
cool.
snap fit, press fit.
Yeah.
So this is a cool little game from, what was it, the late 60s or the 50s, something like that. It was a 8-bit, I'm sorry, 8-pixel 2-bit little display. It's a game. So what you're trying to do here is match a certain amount of patterns in as least moves as possible.
Right.
A cool little brochure that he uploaded here to show all the deets.
This is the brochure from the original Think a Dot. This was developed by
educational something ESR. It's
a
cool little game.
Educational science research in the late 80s. Let's just read his thing. This is great.
Yeah.
We'll walk through it a little bit. There's a little wiki page about it, so you can see here. Is this the wiki page? Yes, it is the wiki page. Okay, yeah. So it was manufactured during the 1960s, and some post-processing stuff here. It's actually colored, not dual extruder. Then you just paint it, color it with a Sharpie. Pretty nice. So nice assembly instructions and photos here too as well. Which is nice. So yeah, he put this together in Tinkercad, sort of his first modeling effort, which is pretty cool. Some history there.
This is amazing.
He had one on hand, so he took it apart to reference it. Digital calipers, patience, and Tinkercad. That's how he put it together. Yeah. Tried to bring it into Fusion 360, but ended up manually creating the fillets on the edges there, which is kind of nice.
Yeah, somebody mentioned earlier they're having a problem with the new fillet tool inside of Fusion.
Oh. Yeah, so take a moment to read through it. Pretty nice. Good history
Jump over
here.
to the overhead.
Yep, okay.
Just seeing text here, seeing some operation from it. So super cool. Usually when you see things like this uploaded on Thingiverse, it's like, I don't know if this is going to work or not. It probably just works for a printer. We're happy to report that it was a very easy build. It is going to take like, I don't know, like a day of printing nothing but this, but the end result is very satisfying in terms of having nice mechanics that work with it. He does suggest, I think it was like an 8mm marbles. I'm just using 11mm marbles or 10. It's all in the description. I'm just using 8 and that worked out pretty good.
Yeah.
Still on the overhead. Just want to show the functionality of it. It works pretty well. I'm really surprised with the way this all worked out.
Yeah.
It's a fun little game to try to, bring back something from the past.
Right. If we take a look at this thing, there's actual like...
Here's all the patterns that you can make.
Yeah, it's like, hey, make this pattern and try to make that pattern the least amount of steps or balls, I guess, required to do it. It's pretty neat. It's good kind of like a calculator type game. It's pretty neat. So there you go. Yeah,
super cool print. If you want to bring back Relic, this is such an awesome way of introducing this to the new generation, because I've never seen or heard about this.
Yeah, from an educational standpoint, like maybe you have a group of kids, have them take a design from the 60s,
that is such a
revive
good idea.
it, you learn history, and then you reverse engineer it by creating, using different tools, modern tools to kind of develop it.
Yeah.
So it's pretty neat.
Super awesome job there, designing this, bringing this back.
Yeah, so check it out. It's on Thingiverse, Think a Dot Replica.
Super awesome.
By Michael.
I've not been able to stop playing with it.
It's fun.
So cool.
All right, cool. Now that the time lapse is done, we can let Gavin play with it. Cool. All right, well, we got some other cool makes here. Going back onto Community Makes. Let's jump on over to some stuff that people remix and publish and post. Really appreciate it. This is a remix of the Raspberry Pi 7-inch portable touchscreen display. This is pretty neat. Low Power Labs on Thingiverse posted this, remixed it to fit some more components and some extra buttons and things. So you can see it has a little tripod thing here, which is pretty nice. So you're looking for a way to kind of do some automation. The Pi display is multi-touch and it works well. This is from the Pi Foundation, so it works out really well.
I like how he's using it. Looks like a security cam here.
Yeah, he also has a
Way to
build instruction blog, so we can check that out. Show how he built it. Very nice, using some power backup and shut-off control. Looks like a Tindy board, maybe. Very cool. So I love it when people do. Hey, Minty Boost! Hey, sweet. Excellent. Nice work there. We got a Pi Zero case. If you want a nice snap fit Pi Zero case, you can download that one. Shout out to Dave for posting his make of it. This is really cool. An update to the Pi Girl. This one adds some sound to it. Very elegant looking design. More of a controller base, built-in support removal. Wow, this is a really great job. Very cool, using all the traditional kind of Adafruit parts on the Pi Zero.
I like how the zip ties are in there holding the USB ports.
Yay, very cool. There you go. If you want to make a cool Pi Girl,
freaking awesome. Even a little stand for it.
Yeah, that's pretty cool. Shout out to Liz Clark, Split City DIY, posting a make of the Halloween M0 Express. Yay. Also check out, subscribe to Liz on YouTube. She does a monthly print things where she kind of does, well, this is an ad, but let's go to her main page. Give her a subscribe. Do some great content.
Really cool 3D printing builds, as well as some cool electronic builds as well.
Excellent. Thank you, Liz. And this is kind of after Halloween. You get to post all the Halloween things. This is our NeoPixel LED gas mask. The person here on Thingiverse uploaded his make of it. Here he is wearing it. Got some EL wire and stuff. It's a fun one. I made this a couple years ago.
Even has a little laser diode in there.
Yeah, I used a PET-G and used an Adafruit Gemma for the controller. Printed on a Prusa MK 2.5 with PET-G. Very cool. Lovely photos as well. Very fun mask. Here's a make of the IoT Gmail box. We did this project in collab with Brent, who works on the Adafruit IoT team. It's a nice little box here. So we printed it.
Oh, okay, that's another make. I was like, did he add a speaker to it?
Yep. Saying, yep, had some screws lying around in the office, but it looks cool, works well. Here's a short video of it working. Sweet.
Again, with the PET-G.
Yeah.
I think it's a sign.
Yeah, we need to use PET-G.
It's always a sigh of relief, though, when you guys post a make.
Yeah, that's great. We really appreciate it, and we'll share it.
I'm just happy that the parts work.
Yeah, right? Like, oh yeah, it actually works. Sweet, so those were this week's community makes. Shout out to everybody for posting their makes. Cool, don't forget, we got a coupon code, Color Swirl, gets you 10% off your order. Also works on, doesn't work on gift certificates or AdaBoxes. Speaking of AdaBox, it's happening, it's coming.
Yes, so you got to sign up now before it gets
too late.
Yeah, before it's too late. We only have a certain amount of boxes that the team is able to make.
Yep.
And we can only make so many, so definitely take advantage right now. Sign up. Adabox.com, I believe, is the site.
Is it adabox.com? Did we get that?
Adabox.com. Yes, get started right there.
How did we do that?
It's going to be an awesome one. You definitely don't want to miss out.
Get started. Do it now.
I think they're almost done with it.
Oh, look, we have a thing. Yeah. Sweet. All right. Well, later tonight, we got some more shows for you. Show and tell if you have a project that you'd like to share, or something that you're working on, or some retro gear, whatever you'd like to show. Arts and crafts are fine too. Everything's fine. As seen on Show and Tell. That's the name of the show. It happens on Google. Is it Google Plus still? Maybe. It's on YouTube and other places. Check out hang out in the Discord to get the invite link to actually tune in. Or not tune in, but like be on the show. So it happens tonight at 7:30 p.m. Eastern Time. Shortly after, at 8 p.m., Marnfell, full hour of Marnfell, new products, CircuitPython segments, open source hardware.
Of course, new projects.
New products.
Products. Yes. And projects. And all the other cool secret stuff that's going on. Yeah.
Ooh. And you also have opportunity to win stuff. Last week, somebody won an M4 trellis, which is excellent, like the whole kit. That was a nice prize. Tomorrow, there's always tomorrow. Jump Park will be live again on every Thursday, 4 p.m. Eastern Time.
Yes. Always working on super awesome projects. Make Code Minute.
Yep.
Definitely check it out.
Yeah. Heading the AdaBox.
Oh yeah, yeah.
Cool. Well, we appreciate everybody's showing us. Wait, I don't know. I'm out of words. There's other people that work at Adafruit. Thank you so much for your orders and stuff. It really supports and helps everybody. Yesterday, here in the States, was a voting day, and everyone got the day off to go vote. Shout out to Lamar and Phil for doing that. It's very, very noble.
Yes. Thank you all for joining.
Yeah. It's going to be cold up there soon. Don't forget, freebies are out there too. Check it out. People good. Go swirl. Can you guys hear the Prusa, man? The thing is loud.
People were saying, yeah.
Aw, they appreciate us. Thank you. We appreciate you. Really do. Can't believe we get to do this. 210 episodes.
Yeah. All right, cool. Thanks everybody for joining. We'll be here next week.
I feel pressure.
And of course, you can follow us on all the socials for some of the behind the scenes on some of the things we're working on. Shout us out there in the Discord as well. You can shout us out there. See, Bill's asking some questions here.
Yes.
We'll get to that after the show.
If I could say shout out to Donald Bell for Maker Update.
Oh, yeah.
Episode 100 is going to happen either this week or next week.
Yeah, shout out to everybody in all the chat rooms. Let me just go through some of these. Arduino, Imagination Form, Tom.
You get a shout out. You get a
Micah got. John Parker's in the chats as well. Dave Estells, Seth Kirby. Over in the Discord, we got Jules, Andy Calloway is hanging out. Bill Binko from AT Makers hanging out. Thank you all for joining every week. Tom Brown in here. Mark Mays. Kita Gut, I think I already said that.
Shout out to Caitlin's dad. Special shout out to Caitlin's dad.
Always enjoy those
always
minion posts.
Yeah, we're minions.
I think
we got a collab on a project where we're scripted minion doing stuff.
I would like one of those as a Christmas gift or something. The little dolls, so cool.
Yep.
All right, guys, thanks all for joining. See you guys next week, and don't forget to make
a great day.
Awesome day.
Here's our fail. There it is.
That's right. Every printer fails, especially
this
if
is
you
our fault.
Orient it wrong.
This is oriented wrong.
It's supposed to be upside down.
Whoops.
But it handled the fail very gracefully. Look at that.
Look at that.
It would have survived.
Maybe. We got some fail art. Excellent. All right, folks. Don't forget.
See you next week.
You got a snake? Deal with it. Look at the snake. Just like, deal with it. This is out of stock. You can't have it yet. Deal with it.
I suggest signing up for a certain subscription box.
Okay.
See you guys next week.
Bye.